Okay, welcome everyone. My name is Beau. I'm joined by another Beau, Preston here, who's going to be giving our presentation today, as well as Becky from the Omni team. We're really excited to bring you today's presentation on engineered stone panel solutions. I'm going to give a kind of quick little rundown about Acelab and what we do. If there's some extra time at the end, I'll be happy to show a little bit more about the platform, but you can also feel free to reach out to me afterwards if you'd like an additional demo. All right, so as I mentioned, I'm with Acelab, so we're helping out with hosting today's presentation. Here's a quick snapshot of the rest of the team. So Acelab is a company started by architects for architects and building professionals, really with the goal to be able to design better buildings and save time and really tackle some of the issues that we were experiencing in practice ourselves. So this is kind of just a little slide illustrating some of those problems or common workflow issues that Acelab is working to tackle. So being able to, save, store, and organize your product research information in one place in a single tab, as opposed to, in many different folders or in, your coworkers' brains. So that was really the vision with Acelab. I'll jump over really quick to our live site and show you where to find Omni on Acelab. And then I will go ahead and pass it over to start with today's AIA presentation. All right, so now that I've logged the account, this is my dashboard where I can quickly pick up on all of the work I'm doing. And if you know the manufacturer you're looking for, you can just go ahead and type it into the search bar at the top. Jump over to Omni's page. You can connect with them directly here and scroll down to explore their products. I've saved these to my project, so I'm just going to jump over and show you what that looks like. So here I created a project and saved a few of these products to my shortlist. And this is a really great tool because it just provides an overview of product information. Scrolling down, you can see finishes that are available, performance data, certifications, as well as downloads, cut sheets, CAD files. So everything is saved and organized in one place. And then this is also a collaborative system, so you can request information from Omni's team. You can also add comments yourself. You can have multiple people on a project, so you can comment back and forth with your project team and use this as a way to kind of add in that additional layer of information that can only come from people's brains sometimes. So if you're interested in exploring a little bit more about Acelab and how to use it, feel free to reach out to me after this event. Here's my email right at the bottom, just bo@acelabusa.com. And with that, I've got a few housekeeping things that I'll go over quickly. So the first is that we are going to send out a link in the chat to sign in with your AIA number. That's just to make sure that we have the AIA number recorded for anyone in today's event. So I'll send over that link in the chat, both at the beginning and the end of the webinar in case anyone misses it. Other than that, we'll also have a poll at the end of the event. So that poll will be a really easy way just to let us know if you'd like follow-up information from today's team. You can request samples, certifications, whatever type of information you need. So that poll will go up at the end, and that's the easiest way just to ensure that you get in touch with the Omni team afterwards. We'll create a conversation right over on your Acelab account. So there's no work needed from you there besides clicking a few buttons in the webinar. If you request samples during that poll, there will also be a quick post-event survey at the end, and we'll just ask you to enter your address in there so that we have a place to send those samples to. And then the last thing from my end is that I wanted to just encourage folks throughout today's presentation, please submit questions to the Q&A. I'll kind of keep an eye on them and see if anything, is urgent to answer, but if not, we will save, about 10 minutes at the end to go over any questions. And also, please feel free to raise your hand if you'd like to ask a question out loud. I'll keep my eye on that as well, but we'd love to have some conversation going towards the end as well. All right, so that is it for me for my quick intro. I want to thank everyone again for joining today, and I'm going to now pass it over to Beau Preston, who's going to be sharing today's AIA-approved presentation.
Excellent. Thank you very much, Beau. Let's see, did I share the right screen? That's always the question. Well, did I? Actually, who can see that? Are we seeing the presentation?
I am seeing a screen. It says Newton Flight Academy.
There we go. Okay, so we're gonna back up here. All right. So quick, a little bit about ourselves. Our name is Omnis. We're out of, we have an office in the Chicagoland, but we operate nationally. We have a national group of reps, and some of them are kind enough to join us today. So thanks from our reps who are here today. We focus on bringing bespoke, unique products from Europe, particularly our wheelhouse is engineered stone rain screen panels. We believe engineered stone are the next evolution of what the United States will fully adopt. They last a lot longer. They carry much larger warranties. They're still operable in the field and make it very easy for our installers. So they cut and drill and are manipulated both in the field and in the factory. So it's very simple to use. They're just significantly more sustainable than the traditional types of products that you and I are maybe used to using on design and in the field. So we got a couple pretty pictures here for you. Lots of really neat projects can be designed with these engineered stone panels. So if anytime, again, as Beau had said, you have a question, you can stop me. I love communication. I love doing these presentations in person. So if you want to make it more human, we can do that. Otherwise, we'll stick with this. I see there's Q&A in chat already, so I'm sure she'll be answering that along the way. Let's see, moving on. So today we're going to talk about, again, engineered stone. We primarily partner with Steny, Petrarch, and Sika to provide those engineered stone product panels. And we're going to look through real quickly which panel is what each panel looks like and some of their properties before we jump into the AIA portion, the credit portion of this. All right. So first and foremost, color. So we've got a vast array of color, texture, glosses, and we're gonna see these. So just show quickly anything from automotive finish down to a matte finish, customization, as you can see there, from any scope over any size. We can do perforations, we can do styrations, we can do true radius, as you see there. We can do closed corners, open corners, trim work, fused corners, durability. We have anti-graffiti, we are impact resistant, and we've got one of the best sustainability stories out there. So we're going to cover all of this in this presentation. This is just very quickly a show for you. So what's important when I measure the importance of a product, and when I personally review products for Omnis or for my other companies, my consulting firm, I measure everything in designability, constructability, durability, and sustainability. Those are, I feel, the four most concise ways to measure a product. And in terms of rain screen, think about designability. You've got to have a wide variety, right? You want cementitious look, you want natural, then you want flashy, then you want images, and you want textures, and you need all those things that we have listed out there so that you can actually meet your design intent. We go down to, once it goes to bid, can somebody build it? We deal with a lot of things like, porcelains and certain sintered stones and certain larger other types of rain screen panels that, terracottas that have to be done in the factory. They need field dimensioning. They require certain aspects that our panels don't. So constructability, does the installer have the ability to actually get it in the field, manipulate it, and put it on the wall? And if nothing goes perfect, which no job goes perfect, can they fix it in the field? Is it going to take 3 or 4 more months while they have to get one more panel from wherever? Rain screens are primarily made overseas, so we need to adjust our business model, and we need to make sure we're using materials that function in that constructability range. Durability. You're going to show you lots of stuff on impact and graffiti and harsh environments. Does it work in cold? Does it work in heat? Does it work in caustic environments like the salt water and such? So that's important. Does it last? And you'll see, we'll answer that question here for you. Then sustainability, operating in a manner today that does not adversely affect future generations. That's the definition of sustainability anyways. So do your panels carry sustainable messages? Do they put their money where their mouth is? Do they have warranties that are 50 and 60 years like Petrarch and Stenny? Do they handle, normal wear and tear? Are you looking around and finding 5-year-old projects with Petrarch and Stenny that are beat up? No, you're not. Are you looking around and finding fiber cements and phenolic panel potentials that are popping corners and cracked from normal wear and tear? Yes, that's unfortunately the problem. And that is primarily why Omnis is bringing these products to the United States. So impact, high density fiber cement, we're all familiar with. We call this real life rain screen. There's Petrarch, right? Real impact, which translates to sustainability. Here's the true ASTM test. So there's Petrarch again, there's fiber cement, right? They look and touch and feel a lot the same. Stenny, there's a fiber cement again, just simple impact test that they use in Norway. That's an 8 mil panel. Now we're switching to a Stenny panel, 6 mil. You could drop that dozens of times. In fact, we did that at the AIA in Chicago, we dropped over 50 times without a single crack or microfissure. Now a hammer, real life rain screens. There's ACM in the middle, ACM bent and tented. You can take a hammer to Stenny all day long. Now look at that, they broke a fiber cement panel underneath a Stenny panel. Just little examples. We have the full array of these videos if anybody's interested in seeing them from beginning to end. But the point we're making is stone carries with it a certain level of sustainability that no other panel is really providing you in the market. Again, Stenny carries a 60-year warranty on their panel. Petrarch carries a 50-year. Just an important message. Why are they 50 and 60 years? Well, both of these panels have been manufactured without major changes to their formulas for 50 and 60 years respectively. Okay, so Stenny has been around 60 years, they warrant their panel 60 years. Petrarch's been around 50 years, they warrant their panel for 50 years. All right, that's the story you want to hear from your manufacturers. All right, how long has your panel been around and why haven't you gotten it right in that period of time? Right, why are they only carrying 10-year warranties? Right, and we'll show you a little bit of why some of them only carry 10-year warranties. So durability, graffiti, like this is Stenny nature, right? It's aggregate face. You would think, no way would the graffiti come off that. Stenny color. All right, picture speaks 1,000 words. First cleaning in 30 years on this building. Just power wash off all that filth from the roof. If that was a cementitious panel, like a fiber cement, that would be stained. If that was a phenolic, it would have a brighter color underneath. It would have faded in 30 years. That's a benefit to a stone panel again. Much better UV resistance. Let's see, so now we're jumping into the AIA. Any questions real quick about, we do have a question there. What about car impact testing? Obviously not at high speed, but low bumps, more specifically stone bases, specifically for that durability. Yeah, it would all depend on the actual energy produced by that car. Now, whether you bump, I've seen they actually do what's called the moon car test for Stenny. They let little kids drive little go-karts into them at a school. So they have done that. Full-on vehicles, I mean, like crash test dummy type things. I've not seen any of that. We've done some pretty fun things. I don't know the kind of energy you would see in a shopping cart, but I mean, the impact of that is pretty high. Now, keep in mind the spacing, all of that would have something to do with it. I would suspect that Stenny would do exceptionally well if you took it to some very high-end impact testing. Petrarch's a little more rigid, so it would bend first before it breaks, but Stenny bends and can be pushed a significant distance before it would ever break. I've never been actually able to break a Stenny panel, whereas you can take Petrarch to its limits, but they both do true radius, which gives you an impact or gives you an idea of how much give they would have before they would succumb to an impact. All right, should we leave these questions towards the end? Beau, what do you think? Or should I just handle them?
Yeah, I think if you want to go ahead and just like run through the AIA, I think we'll have some time to answer all these at the end.
I do appreciate these are good questions, Victor and Brian. I will get to them, so don't think I won't. So
Yes,
we'll jump down
and
here.
we'll have a record of all the questions. So in the event that we don't get to your question, we'll follow up with you after the event.
Perfect. So this is AIA HSW. You'll get your credit. We'll figure that all out. And there's a bunch of you here, so it might take us a couple days to run through all that, but we'll get you there. And I'm going to draw your attention to some of these photos here. So as we go, this is AIA, but that's the Natural History Museum in London. All right. And as you see, because later on I have different photos of it, but you see the people are touching those panels, right? Those panels have been there for 30 odd years. All right. So 30 years of a rain screen panel at ground level. They have 5 million visitors a year. That is 150 million people leaning against, touching, gene rivets, baby strollers, you name it. And if you have been there, I've been there a couple times. If you've been there, that's insane. I mean, the durability of a panel like that is what you want to see. You wouldn't do that with a fiber cement panel because you can scratch them with your body. You can scratch them with your nails. That type of stuff, it speaks volumes. And I think that's very important for you to understand. So we're going to follow the evolution of engineered stone rain screen panels, investigate its impact on sustainability, versatility, and constructability, which are some of what I've covered a little earlier. Again, drawing your attention to the one on the left, that's a true mural. So being able to take any image over any size, over any scope. There's a real fun story to that mural, but that's a self-portrait of a real artist who used to live on that block in Denmark. So very neat things. So today we're going to be able to define sustainability and identify how engineered stones contribute to the 3 pillars of sustainability. That's economics, environmental, and social. We're going to understand versatility, again, designability, and engineered stones, their constructability, and then how they're compatible with your own design intents. So standing the test of time. So here's the part, if I was in line, I would ask you a question. Maybe you can answer in the chat, but if you were to think about any types of products that you could specify on a building today that you could also specify in their same format, in their same formula 50 or 60 years ago, what comes to mind? I mean, things change so frequently, so furious in our industry. What doesn't change? Which products have stood the test of time? In the chat, I don't have anybody in the chat. Does anybody see that? Okay, we're getting them in the Q&A. Good. Brick. Good. Stucco. Yeah, cementitious there. That works. So we had a lot of innovation in stucco in terms of not bucking water and making sure we have drainage and the quality of the insulation behind or cantilever because we have CI. So a lot of innovation in stucco, but stucco itself, the final layer, sure. Anything else? What else? Three, two, one.
Brick
Stone, right? Stone being a big one. Glass, right? So yeah, we have more layers of glass, but we're still using glass, right? Over and over and over. We haven't replaced glass with polycarbonate or something like that, right? So we're still using, because we found that natural materials, and the more natural a material can be, the more it starts in that realm of sustainability, right? So think about, look at Bodiam Castle in the bottom right here. How many projects could you build in the middle of a pond and expect it to be around 700 years later and look good and still win awards for being one of the most symmetrical and most beautiful castles in the UK, right? So not many things, not even brick, right? Obviously, that's a small, they called it a church. It just looks like a hut, but it's in the top left. That's in Southwest Ireland. That's been there 1,000+ years. Right? Stonehenge, 3000 BC. So we're pushing on 5,000 years, right? That's a big deal, right? So these types of things, stone is the pinnacle, it's the linchpin of sustainability. It is operating today as it did yesterday, as it did the day before. Future generations, it's going to operate pretty much the same way. And then we mentioned brick. So Victor mentioned brick. Thank you, Victor. I kind of have a theory that brick is mankind's first VE, right? And I'm not saying it from a bad sense, but think about every time that we VE, value engineer, for those who aren't familiar. If you're not familiar with it, you're a very lucky person. But think about it from that perspective. Every time that we move the needle in the value engineering model, we are trying to gain efficiency. Efficiency relates to today. Sustainability relates to future generations. So efficiency and sustainability live on the spectrum. In brick, thinking we were stone, at some point, somebody didn't want to latch up their mule, drive or ride 2 days to a quarry, lift 5 stones into the cart, and then go 2 days back because they're 2 days from, mule ride from a quarry. What they decided to do instead was dig up some clay, start a fire, and make a homemade stone, right? So they gained efficiency by proximity and cost to actually procure that. What did they lose? I'm not saying, don't get me wrong, brick is a sustainable product. It's just further down that spectrum. They gained efficiency, so they lost a little bit of lifespan, right? So stone is the pinnacle. Brick is a man-made stone. It's an engineered stone. And now they get efflorescence. They get more of a reservoir wall, meaning they're absorbing moisture, whereas versus stone would often get rid of the moisture. Certain stones will absorb moisture, but not the ones that we purposefully put in the wall a lot of times. So you follow, we're just following a little further down the efficiency, gaining efficiency, losing sustainability. Engineered stone, obviously we're going to chat about this real quick today. Picture on the left is engineered stone hospital in London. I forget, Bex is from that area. But apologetically, that's the color of everything in London. That's been there 30 years, if it's not marble and bright white. But those that predates rain screens. Those panels are glued and screwed on there. And if you think about any other panel that you would use today, which panels could you actually glue and screw to a wall and take a picture 30 odd years later and see something monolithic that's not rotting or falling off? That's the benefit of an engineered rain screen facade. Engineered stone rain screen facade. The one on the right, we showed you the video earlier of them cleaning that. That's after 30 years. Look at the color. The color, although it's not a beautiful color, it's consistent. The one on the right, when you clean that and when you see the rest of the video, it's pearly white again. Any other white panel on the market, if you were to do that 30 years later, it would either be stained permanently or it would be faded disproportionately, because that mold and mildew would actually block UV from something, say like a phenolic. Okay, so having this consistency is a real big deal. Engineered stone, and now you're looking, you can do all kinds of things. We have renovations at the top left. You've got terracotta look on the bottom left. You've got unique designs in the middle, and then completely bespoke printed images on the right hand side, just really breaking the molds of what rain screens are supposed to be doing, or what rain screens has offered the United States up until this point, until you've discovered what Omnis has to offer, has been limited. We're opening up the limitations. Going to fiber cements, this is what you see when you look at 5 and 10-year-old fiber cement projects. You're seeing cracks, whereas it feels real tough. It feels strong. You have 2 pieces in your hand, and I think Victor wanted to know a little bit more about this. One has Portland-based cement and some fiber, and it's a hatch check machine. I can get deep into those weeds if you'd like to, Victor. I'd love to have that conversation with you, but they snap. Break one over your knee, break it on the ground, drop it. The way they feel in that sample that you get from your rep is not how they operate in a 2-foot by 8-foot panel. The one in the middle there, that's simply resting it on a boot. That's what happens. So they're a lot less robust than what they feel like in the sample state of things, right? The one in the middle, or the bottom left, you can see that simply cracked under its own deflection. snapped right down the middle because it's too tight. You can see that it's overlapping, it's shiplapping on its own. That means they didn't drill the holes well enough and they're pressing against, and the whole panel is expanding thermally or hydrothermically, and it's breaking. HPLs are great as well. We're leaving the spectrum of natural and going all the way to 100% man-made, right? So if you look at an HPL, they're fine, and some of them are actually quite gorgeous. Some of them have real wood. Example bottom right there, that was a real wood, but you can see they're laminated, and when you have things that can wick, and you have real things that are they're stained. They're stained with a film, or they're stained with actual stain, or they're an image on a piece of paper, right? And so we have sustainability issues with HPLs. HPLs have reformulated dozens and dozens of times over the, that's an exaggeration, a few times over the last couple dozen years since they've been invented, but we still have issues with things like delamination from time to time, or the edges discoloring, or wicking in water around the edges, and so you get a small mushrooming and various things that they have struggled with since their inception. So there's sustainability questions with these. Again, both of these panel types are going to meet you with a 10-year warranty. Why? Because they've never gone 10 years without having to reformulate or fix a problem. That doesn't say that they won't finally get it around someday, but it's not today, and it's not yet. So weaknesses and flaws overcome by engineered stone, as we covered top left, rips and cracks. The one on the middle left here, those are all the same color. Those are panels that are ordered whatever color gray. Now you see that some decided to effloresce at a different rate than the others, right? And you see that the darker ones are what we call ghosting, which means you've got moisture issues, meaning they absorb moisture, meaning that you can see the moisture ghost through there. What will that do? Well, if something's wet next to something dry and pollen comes through, the wet will attract the pollen and hold it there. The pollen will then turn from green to black as it rots, and you will get staining in the form of ghosting. So you're ghosting, even though wet, you'll say, well, it'll just dry out. And that's fine, and it may, but not before over time, those areas will attract more discoloration as a result of their hydrothermal inefficiencies. Okay, the one in the middle, that is a high density fiber cement installed as if it was an HPL. HPLs can be installed with screws that are 1 inch from the edge of each panel. Those are obviously only 1 inch from each panel, and high density fiber cements need fasteners that are 2 inches from the vertical and 3 inches from the horizontal. And what do you have there? If you don't do that, you have 100% joint or a corner failure. You will have a panel that grows and will pop a corner so that it fits in the space that you gave it to fit in. All right. Again, engineered stone is not requiring that level because they don't pop corners, because they don't thermally and hygrothermically cycle the same as these submaterials. Okay. The one on the right is a very fun picture. Literally the furring is popping out of that high density fiber cement, ripping out like the movie Alien, which is kind of funny. It's only kind of funny because this was actually one of my projects in the Carolinas years ago. And it wasn't fun to fix, but that's a different story for a different time. So stone, why do we want stone? Because we don't want those problems, because we want to fix, we want to offer more. We want sustainable solutions that offer long warranties that stand by their materials. So how do you make an engineered stone rain screen panel? And Victor wanted to know what the difference is. Notice there is no cement in this panel. The Petrarch line has reconstituted marble. So it's marble, it's fiberglass chopped, it is some quartz, it is pigment, natural pigments, and then it is a resin base. So you have, I don't know, 3 to 5%, something like that in resin. The rest is natural materials, 80 to 90% natural materials, depending on the build. and you have an engineered stone rain screen panel, right? Looks and feels, the Petric line looks and feels like a fiber cement to a degree, but it feels a little bit more classic, a little bit more stone. We can add slate and quartz and other stones to that to make a really nice kind of natural feel. The Steny line is also an engineered stone, but it's much flashier, and we'll see lots of photos of that in a minute. But the core is like the top left here. The core is like concrete in the sense that it has aggregate. So it's got a crushed limestone aggregate core with 2 layers of fiberglass mat running the whole length, chopped fiberglass integrally, natural pigments and acrylic, electron beam cured acrylic coatings for the color, ink jet printed images, and then real aggregate facers for the one of their other options. So you see they have lots of different facer options. Again, very natural material, exceptionally resilient, impact rating, and they both have the absorption level of porcelain as a result. So that is dozens of times less absorptive than fiber cements. Okay, so they're not going to ghost and do that. They have again, the capabilities of porcelain. And then because they're that way, they don't hygrothermically cycle the same way. They're not expanding, contracting because the moisture in the air is absorbing into them like some panels do. Thermally cycling they do, but much less because of their makeup. So reconstituted marble engineered stone, we were talking a little bit about this. This is in University of Connecticut. Just won a nice award for this job, or the job won award, we did not. So very beautiful rec center at UConn. Very classic look, monolithic in color, completely customizable, as we touched on early, but just a nice image, 50-year warranty. That's the type of thing you want on a university, because those buildings, they want 50, 60, 70, 80 years, right? Crushed limestone core, engineered stone. So this is the Steny line. We see you can do bespoke images. You can do any color. You can do well, we'll jump into more of that, but it's completely customizable, very unique things. And they don't run from really any opportunity. Okay, we run to those opportunities to do things for you that you wouldn't have thought about rain screens for. So now constructability and designability, the things that make it fun to use a rain screen, or what do these overcome that rain screens say, nope, you can't do that, right? So what changes to the game do engineered rain screens provide? So think about an open joint rain screen. What's the biggest issue people have with open joint rain screens? Some people want all the benefit of an open joint rain screen, but man, do I hate open joints. And so we say, well, within reason, well, let's close them off. We don't thermally cycle and hygrothermically cycle the same way. Let's make sure that we're making a ventilated facade still, but we can, on that first floor or on multiple floors, we can put bird's beak trim work, as you can see there in the bottom left. We have martlet joints where we do these overlap, shiplap joints, and it still looks like a joint, but it's actually closed there. Or we can do traditional open joint, which I think is the highest and best use of an open joint rain screen, because you get the best equalization of pressure in the wall. We can still mitigate those with the other ones, but easiest is to keep an open joint, but we can do all of that. Most will just say, hey, we're an open joint rain screen, have open joints. We can have trims, we can do martlets. Here's some better examples here too. We can do shiplap rain screens. Have you seen or thought about doing the fish scale rain screen, as you see in the bottom right? Very cool design. Anybody who wants to do that, I want to be a part of it. Somebody write me. Let's get the details. This would be something that I think we need to see in the United States. Right now, there's a couple really good examples, one in Canada and one or two in the EU. So let's see.
Real quick pause you, because I just noticed someone raised their hand and maybe they're volunteering. Oh, they unraised their hand. But I thought maybe they were volunteering to do this project with you.
Let's do it. Let's do it. I'd
Let
love
us
to
know after then if you're interested.
Okay.
Cool.
And then now a big issue that people have with open joint rain screens, particularly when they have cores and different colors and such as what do we do on the corners? The owner doesn't like the corner. The owner doesn't want to see in there. And when you do come around a corner, you have to pick which one's sitting proud most of the time with a rain screen. And if you were walking there, you know, the vulnerable joints on a rain screen that you can physically see into are vertical joints. So how do we mitigate the visibility and, you know, the fact that they're usually not level and plumb? How do we get a nice looking corner on this expensive facade, you know, so most rain screens say, well, pick which one you want plumb, pick which side you want the corner to show, and tough luck. But that's not what happens with engineered stone. Look, we have corner profiles. So we have 3 different corner profiles that we can actually do to bring them together, to hide the edges, and to give you another color pop or to make it match in that corner. We can actually do formed corners. We can fuse these corners together and actually do nice corners, place that L or U element on the wall, and then change the body to make sure that we're level and plumb, right? You put that corner on first and you fix that problem. And then you work your way into inside corners, which are a lot easier to fix than outside corners. And the first panels to, you know, if you're really out of plumb or really out of plane somewhere, then we can fix that with these types of corner pieces. We can do butt corners that are actually fused and they just look like a traditional rain screen. Here's a good example there of a quirk miter where we can do that fused, and that product there is the only rain screen I know that actually can take that corner and can cantilever that 6-inch leg up to 6 inches. What does that do? And here's a good image. What about your window returns? What a terrible detail that we have to figure out in the design community every single time. How are we doing the window returns? What's the CI in there? Is it an innie or is it an outie? Is it a flange window or is it commercial? And then that layer changes, that depth of the window return. So are we doing what I call the good grief method, which just looks like Charlie Brown's mouth, which is just sheet metal, right? So we trim some sheet metal and it looks like the good grief method from Charlie Brown's mouth. But or we do a cantilever. You know, most of us who have designed with rain screens want to do a return with those rain screen panels. They want that monolithic look. The problem is, again, with a phenolic, you have to have, generally speaking, phenolics will not allow a single fastener line. They want one on each side, and they need a minimum of 1 inch. So you have to have an inch. So you can't do a 2-inch return. You couldn't do a 2.5. 3 would be right at the cusp. And then they want 2 fasteners in each of those. So you've got basically what looks like a battleship in each of your window returns, where we could do a clean cantilevered, and you wouldn't have to change any of your CI. You wouldn't have to move anything out. That's a very unique, and that's constructible. There's an answer to a question and a call that the design community has asked for. Here's some more examples of formed corners and how they look in the field. True fused corners, true butt corners. If you like that look, we can make them look good. All right, but we can do any and other options that basically nobody else is doing. Some more examples with the crushed limestone. Now you can see it doesn't even have to be 90. We can do anything from 180 to 90 degrees. We don't do acute, but we do all obtuse angles, okay, and full U elements if need be. Now colors. On the engineered stone, the crushed marble, or the reconstituted marble, you see in the bottom left, there is 1,500 custom colors. If you look online and you look at our webpage or anything like that, there's 20 standard colors or something like that. Not a ton, because it's all natural look, right? It's all how many tans and taupes and grays and blacks and whites can you have? We run to the opportunity to customize one of those. We take that as a base, and you say, well, I'd like a little bit more speckle in there. I'd love this red to be redder. I want this red to be orange-ish instead of red for my terracotta, my faux terracotta. We do that. Those are the 1,500 times they've done that in the last 50 years for projects that have went. So not only do we do that, we run to that opportunity. We appreciate the opportunity to do that and give something bespoke for you and your project. Okay. Here we've got color and texture. And when I say texture, we've got texture in the way of glosses, and you'll see some of the examples like that first picture. That's the same color. That's a diagonal rain screen that has joint fillers, that has matte and high gloss. I mean, those are things we don't have in the United States, but we do now. There are no other panel manufacturers who are offering or encouraging that type of design. Look at the top right. That's every color you were told by the metal panel manufacturer to stay away from. Bottom right, stay away from that. You don't want this to fade. You don't want to use yellow. Don't you dare use red. Don't you dare use pink. Don't you dare use purple or dark blue. Those will all fade. Those will all change. These guys are running to those opportunities. If you don't see the color you want, they'll do any raw number within reason. I say within reason because they use natural pigments. Sometimes there aren't natural pigments that you can mix A and B and get C. So they'll get you as close to any raw number as they can on Earth and do matches. And we've had good success, but I would be remiss if I said there was 100% success in matching it. But there's a 100% chance they will try and they will send that to you. Here's a good example. The top pieces are precast. Underneath, that's a reconstituted marble precast color match. So something, and forgive me if you use a lot of precast, something is kind of elementary, normal, or boring, whatever is a precast panel is what you got to do and tip up or whatever. We can do a rain screen. I mean, we can match. What if it was a project that already existed at a hospital that had old precast and we want to match with something more modern? We want the color, but we want a better system. We want a lighter system. We want a less expensive system. What if you've got to have something that's similar? We can do that. We run to that opportunity for you. Here's a quick example of that and how they match. I'll take a drink while we watch the movie. At the same time, I guess you get an understanding of how Petrarch is made, just a slight handmade version of it. So very good. All right. And then here, I guess this is the other one, Stenny. So matching varnishes. So here's the natural pigments that they're doing, trying to match that exactly for you. And that's the lab. So if you wonder why your match looks this way instead of it being on a panel, that's what they're going to show up like, and they'll cut that out for you. Here's a good example. The picture on the left that just finished up. It's a project we're very proud of, just finished up in Jacksonville, Florida. You can see there's 14 colors and textures and different glosses. You can see the reflectivity in different parts of this building. You can do that too. High gloss, half matte, and matte finish. Any number, any scope, any size. Every single blue on there was a custom blue. Architect did not like the blue offering, so made his own. And it was fine and was good. And now we've got a gorgeous project that we can all be proud of. Texture. And again, I said that we have aggregate face. Now the one on the left, the image on the left, we actually can do all of this in stone, but now we're doing this in recycled or upcycled glass, okay, which would be waste material. That's something worth mentioning, and I think we'll get to it again later, but all these materials, all this crushed reconstituted marble, all of that stone on the top, all the stone in the core, those are all upcycled materials. And they were just waste product. There was nothing left. It's the dust and debris of making a countertop. There's the dust and debris of sending pea gravel and other limestone products to other places. We're using the crush and the dust and the leftover to make rain screen panels. So you've got a very good carbon footprint because it was, absorbed into the primary product. We've just got a good story when it comes to all that. On the reconstituted marble, there's 4 finishes. A 5th if you count the fact that we can hone it. But you've got a smooth matte, meaning you can shot blast this material. And so it takes off that kind of half matte finish, that kind of half gloss or whatever, and gives it a real stony, marbly look to it, right? A cementitious look. And then we have what's called ribbon. And ribbon is pressed on a piece of Welch slate. So it's got a true slate image and finish on the face. And then you can shot blast that as well to get rid of some of the sheen. and then run into every other type of customization, routing, wall saws. We can create custom molds. We can do images and 3D images, and as you see on the bottom row. So running to those opportunities for you again is what our company is here to do. We want to break down the barriers of what you think rain screens can and should be doing. Images. It's a new one. The middle bottom or the middle left is a new one for me, so that's kind of funny. We can take any image, be it geometric, be it a picture, be it a mural, be it anything, over any size, over any scope. And it's the only company that I know of. If you think about when you look at an image, when you look at an object or a sample, you're looking here. But what if you wanted, and let's just say something simple like wood. What if I wanted it to look like wood here? But what if I wanted somebody to recognize it as wood from 100 yards away? What if I wanted it to look like a forest from 100 yards away? Would it just look like a big green panel from there unless I zoomed out, right? So these panel manufacturers can actually zoom out so you can look and see and observe what you want it to look like from any distance. Now up front, it would look more pixelated and big and blown up. But from whatever distance you want to design your building to be observed from, they can take images and do that too, which is fantastic. You should see some of the things that they've done, and I would highly encourage you to do additional research on it if you like murals and if you like images on rain screens. So versatility, you can see over and over and over, we are next to water. There's perforated imaging, there's soffit panels. Here's true radius from both panels. I don't know many rain screens that would run to that opportunity, but true radius. We do a lot of adhesive fixing through our partner Sika. So we do concealed fastened systems with 20-year warranties that cost the same as a face fix. So you think you can only afford the rivets and the screws, but no, you can do the adhesive for the same cost effectively, plus get a warranty on the attachment method. Very unique. It's the #1 way that we're providing panels in the United States, and it's highly sustainable. That attachment with structural silicone is stronger than the rivets. It's stronger than the mechanical secret fix you see here in the images. Now, durability in the snow, down to the ground, at schools, at football stadiums, interior, exterior, in the grass, in the dirt. That's a school in the bottom left where you have entryways, right? We covered this in the maintenance. So now we're going to cover a little bit about sustainability. You think about this project here was actually, let's see if we got the image of it. Maybe we don't. This project was the beginning of something called Steny reuse. Basically, those were on a building for 30 odd years. They tore that building down for whatever reason. I don't know the story to that. They took the panels back, they cleaned them, they cut them, and they put them on a new building and gave them a new warranty, right? So they are creating and reducing landfill. They're creating systems and again called Steny reuse solutions for people who need to use panels over and over again. So the owners of these buildings can literally own their panels, pull them off, put them on a new building. They can paint them. They're one of the only panels that could be repainted if you wanted something else. And they last literally for the lifespans of buildings. Economically, we covered a lot with stone, but the nice thing about these panels cost the same as their competitors. The crushed aggregate core costs the same as HPLs. The reconstituted marble costs the same as high density fiber cements and much less than ultra high performance concretes and porcelains and sintered stones and things of that nature. So there's a big opportunity to work. And that's because stone doesn't actually take a long, over the cost of its lifespan, it's very low maintenance. So it's economically quite sustainable. Environmentally, Sitting has the lowest carbon footprint of any advertised. If somebody's out there with a lower carbon footprint than they're not bragging about it. So I can tell you that they have one of the lowest carbon footprints in the market, naturally derived material, upcycled content, easy to clean. We've shown that, easy to fix with graffiti. Installs the same as anything else. So you're not asking your construction professionals in the field to be perfect all the time, to field dimension to the minute microscopic inch. You know, it's like they can take a saw and chop it. You know, oops, it's a little off. Let me use the attic stock and fix it. And so we don't have to worry about this. There's your carbon footprint. So you see engineered stone is half of fiber cement and brick, 1/3 of HPL and ACMs. All right, ACMs and the HPLs are about the same. So strengths, again, they cover every aesthetic of a flat rain screen panel. They are every combination of color and texture and corner and designability. They do meet the 3 pillars of sustainability. Again, high upcycled, it says recycled, but it's upcycled content, usually would be waste product. 50 and 60-year warranties. We have 40-year projects in the United States. There are not 2 other rain screen panels. There's not 1 other rain screen panel that has been in continuous use in the United States longer than either one of these panels, right? So strength, durability, lightweight, you can read. Couple pretty projects. This one's in Brooklyn. Notice these panels are on the streetscape in Brooklyn. That is not something you do unless you are confident in your panel's abilities to handle what Brooklyn has to offer. Okay, and the boroughs have unique offerings for rain screen panels. So be careful. There's another one of our First Baptist Church. UMass Football Performance Center, Radius for decades now. Beautiful examples of columns, and see those corners? Those corners are cantilever corners. So they did U elements around to take your eye away from the corner. Takes it around, gives you a nice rain screen joint. So aesthetically, very monolithic. I think very classic look. Your most expensive liquor store in Arkansas, but definitely a rain screen. Hoboken, again, schools. Boston, we just finished this one up, or just got some photos of this one, actually, 2019 finish. This was the mosque in Oslo. The only original piece of tile on this whole mosque is that awning right in the front. Every last bit, what looks like tile, is a stemming panel at this point. They took images, and you see the blow up there. We even have their grout lines in the rain screen. This one's up in Canada. Love this one. The mix of these triangles with the high gloss. Chula Vista, again, in the end zone, where footballs hit, where people hit, where soccer balls hit, where all the things hit these panels. Those would break fiber cement. I guarantee it. I have good examples of that happening. This impact rating is much, much higher. But then again, gives you that classic look that you might want from them. These panels line the inner walls of the entryway to Comerica Park in Detroit where the Tigers play. There's just a lot of places that last and stand the test of time. Here's a terracotta look. If you didn't want to wait a year for terracotta, if you didn't want to pay $75 a square foot for terracotta, but you want a 50-year warranty and you want the look, we have that opportunity. Regal monolithic buildings. It was a renovation. They did all the part with film works and just renovated that building. And this was an example about what I was talking about. Like up close, you would never know that you're holding a panel of fish scales. But when you drive by on the neighboring mountain, you see that this building is actually fish scales of the Salmon Research Center. Right. So they blew that up so that their observer was not ever walking in the yard next to it. They're observing from afar, right? So you could do that with anything you'd like. We covered this one. Let's see, for sake of getting to some questions, I want to jump through. Here's that example of that building that they pulled off the old panels in the top left and put it up. Yeah, I knew we had this somewhere. There you go. There's the moon car test for those who are asking about driving vehicles into it. They let these vehicles drive into them, just to prove to the school that the standing panels can withstand what children have to offer a rain screen panel. You see they're right to the ground, right to the concrete, only enough for the air intake and the air exhale at the top, and they're on a radius as well. So please follow us on LinkedIn. That's the end of this presentation. I'd love to answer the questions. If you get a chance to hook up with me on LinkedIn, I'd love to do that. Have any questions? It's a quick way to get with us and follow what we're doing. We're doing a lot of beautiful things in the United States, and love to do some stuff with you. So with that, Beau, do you want to direct questions, or should I go to the top? What would you like to do?
Yeah, so first just wanted to mention, I know a lot of folks have already filled it out, but the poll is still up. So if you'd like follow-up information, please just respond to that poll. We'll set up a conversation over on your Acelab account so you can get all your follow-up information over there in one place. All right, and then let's move on to the Q&A. And I know we've got a lot in only a few minutes. So if your question does not get answered, don't worry, we'll have a record of it and we can follow up with you after the event. So I'm just going to go through here and kind of skip some of the ones that I know we covered a lot. And then Brian's questions, he let me know that he left the event early, so we can skip his, but he would like to be contacted after the event as well.
All right. Victor had a couple good questions. So I think I covered what they're made of. The Petrarch is made of, basically they take 80% marble, dust and powder and granules, add other natural materials like slate and slate powder and quartz as filler. They make a stone dust filler. They add a small amount of resin. They do chopped fiberglass and pigment, and they make that into big silly putty. Basically, they run it through and make panels, and then they press it under heat and pressure, and that's how Petrarch's made. Steny is, again, crushed aggregate core sitting on 2 layers of complete layers of fiberglass. They take a stone dust and resin powder mixture and impregnate that whole bit, cure a panel that's 6 millimeters, and then they do either put the aggregate on the face or glass if they do that of the Steny nature, or they do an image. So they do a what do you call it? A base coat, and then they'll either print the image or they'll put their color and sheen and all that on it. It is all reinforced. That's the engineered part about it, but none of it is cement. There's not Portland cement in any of the panels. So therefore you will not get any efflorescence with these panels. They will not fog over like fiber cement panels do. They will not fog over like ultra high performance concrete. They will stay color true for ages and ages. All right. The weight compared to fiber cement. Petrarch is 3.2 pounds a square foot. Fiber cement at 8 millimeters is 3.5 pounds a square foot. Petrarch at 7 millimeters is 3.2 pounds a square foot. Steny color is 2.5 pounds a square foot. So both of these panels, even though stone, are lighter than their competitive products. Explain the mural process with the stone and approximate cost. So the process would be, Omnis has our inside sales manager has a graphic design degree. So he is our liaison with their team, Steny in Europe. And he will work with you, if we have to vector something, we will get the right file. I'm ignorant to that, those file types and such, and the size, but the scope. So there's 2 people who are working, one on US soil, one with them. A bespoke image over any size like that, we're talking probably about a $4 to $5 a square foot delta. So whereas normal Steny color is about $12.50 for a panel per square foot, you might be $17, $18 for that, just the muraled aspect. You can put all your other color in there and then bring your total price per square foot down, but it's highly inexpensive comparable to other solutions. Okay. How do you install printed artworks to engineered stone? So they are printed, and it's like a sheet of paper. Like if you sent a file this big and fed one piece of paper at a time, the computer and the people who lay those out, it would all be printed perfectly. You saw the mosque, right? So that definitely covers that. How do they hold up in extreme heat? I've done several projects in desert areas. So in extreme heat, they thermally cycle less than the plastics like HPL. They thermally cycle less than metals and plastics like ACMs and plate panels like a dry design or something like that. Do we move? Yeah, everything does under heat and pressure, but our stone has a much more forgiving amount of thermal cycling. Okay, got lots of really nice southern part of the United States projects. I've done a lot in the Carolinas, and I could get with you, Karen, about what we saw and what it did to the envelope. And we use the lighter the color, the better too. So like I think that naturally occurs in the South. We naturally gravitate towards lighter colors, and that really helps. Amy, is there a minimum project size or order square foot requirement for your products? The truth is really not. So we have some small order charges that we incur, and they're different between the two, but they amortize. So we do a lot. I'm doing, we're doing the Greenville Art Museum, 350 square feet, just the entryway. We just finished a beautiful project. It just hit our Omnis LinkedIn today. You can go look at that. Just the entryways, cleaning up an old school, and beautiful, just fire engine red. Go take a look at that on our LinkedIn. You can see it's quite affordable and it amortizes well. The biggest issue is shipping, right? So we ship a lot of things together to try and reduce that. So we do everything we can to make sure that small quantities are not prohibitive for anybody. Can you list some of the sources, the mine's location of the crushed stone? Good question, Hanson. The truth of the matter is the fiber, all the limestone is procured in Norway or Denmark, I think, or the Netherlands. It's all within those three countries for Stenny. And I couldn't name the mines, but they're all there. The crushed or the marble panels, they go from all the actual mines, like the Carrara marble in Italy. They get stuff from Carrara. They get the green marble from the Irish marble, the green Irish marble. Everybody has the bracelets when they come back from Ireland. They get them from the same places you would get your countertops. They just contract and say, hey, how much to buy all your waste for you to put that in a bag, and they basically get these big bins into hoppers to do that. What was the kindergarten in Finland? That was the one. I think this one is the kindergarten in Finland. Outside of that, I don't understand the question, but that is the kindergarten in Finland. They have this school. I've shown you 3 schools there. This one is also a kindergarten in Finland. So they're not afraid of kids, and either should you be. So cost per square foot for printed panels. Sorry?
Oh, it looks like we have someone who raised their hand. So I just wanted to check, Sam, if you had something that you wanted to talk about. But if not, it might have been a mistake. Sam? No. Okay. Looks like it was a mistake. Just wanted to check. So feel free to keep going. And thank you to everyone who's sticking on a few minutes late. So we can, keep going through these questions, Beau, as long as you're good to go.
I definitely appreciate it. So yeah, I'll keep running through these. Ballpark cost per square foot for printed panels. So the only way that you can actually compare range screen panels, because the installation's all the same, of the base panels. Everybody's got to cut, everybody's got to drill, everybody's got to ship, everybody's got to buy fasteners, they've got to do all the same things, apples to apples. So our Stenny panels are the aggregate face are about $9 a square foot, which is way less. That's less than a Nichiha panel. Okay, the Stenny color panels are about $12.50. The images, if there are standard Stenny Vision, those range from $13 to $14, something like that. And then the bespoke ones, like you're looking at here, that might be $18 or so dollars. But just for the panels, you can see they have green and solid colors around them. The solid colors around them would reduce the overall price per square foot, because they would be $12.50, if that makes sense. Okay, Petrarch is about $13.50 a square foot. That's it. And that again is in line with high density fiber cement and way less than ultra high performance concrete. What is the comparison between your products to precast concrete products? Precast concrete's all over the board. So we're gonna be lighter. We're gonna win on functionality. We're gonna win on variability. We're gonna win on detailing. We're gonna win on everything but panel size, probably, right? I mean, and then I'm sure there's some very inexpensive options for precast, just like that range. I'm sorry I can't answer that better, but I can tell you that nothing a precast panel is going to do is going to amount to close to the installation capabilities and the customization capabilities of a Petrarch panel. What is the range of cost per square foot for engineered panels? We covered that on the cost. Most places in the United States, you can get a reasonably a job with a reasonable wastage. So like if you design with 3x6, that's on you. You have a high waste, but 10% or less wastage on a project. And we're installing for majority of the United States in $45 to $55 a range on the wall. Some of the higher markets, West Coast, New England, New York, Denver, for whatever reason, decided they want to charge twice as much as the rest of the country. Those, it goes up from there, another $10, $20 delta probably on that, but that's just the market. That has nothing to do with the panels. Great presentation. Thanks, Mary. Have you sent this material? We use this material with mass timber. It's a good question. We have certainly been in conversations. I think we have some designed with mass timber right now. I don't know that I have an installation that was maybe is the best I can answer. I apologize, can't answer that very well. Are the Stenny Vision panels transparent or translucent? No, they are a vision in that they can create anything to any visage you would like to see. New York City requires stone coverings to be 1.5 inches thick. So you install a panel in Brooklyn, so did you use special consideration to use a thinner panel? I think I know where you're going with that. I've read the new code on stone. These are an engineered stone, which has to be a whole different thing. So we actually compare ourselves to fiber cements and HPLs and operate better than they do. So we get EJs because they actually cover HPLs indirectly or fiber cements. Engineered stone is a lesser generally accepted product than those front runners, first movers. So we don't operate under the guise of trying to be stone. We operate under being, hey, we're a range screen panel with better guts, better sub materials. EPDs, Stenny has EPDs and HPDs. Petrarch has one of the two. I don't remember which one. I don't know, I'm drawing a blank on that right now, but we do have some HPDs, and we can, how you get them is ask. We'd love to give them out. We have, they're probably on our website, so we'd happy to do that. They're definitely on each manufacturer's website as well. Any chance of these being manufactured stateside in the future? Shipping stone across an ocean seems less than sustainable. Good question, David. There's only now 2, maybe 3 manufacturers of any type of range screen panel, period, in the whole United States, and we have advertisement. Stenny has a lower carbon footprint than they do, with shipping involved. So there is a chance that the Petrarch line someday could be probably done here. Stenny used to manufacture in the United States. They used to have a place in New Jersey years ago. I don't see that happening unless we as a community build a heck of a lot more Stenny clad buildings. But any chance, yes, there's always a chance. The United States is moving more towards a service-based country every day, so the chance that we had major manufacturing of something like this is less chance, I would guess, but that's just my personal opinion. I would love it because I would be integral to it, but I don't know that I'll be given that opportunity anytime in the near future.
Awesome. I think that looks like it for our questions. Thank you for running through all those. I know we had a lot.
Yeah, lots of good questions. I'll stick around for a second if anybody wants to unmute and ask, or I'll slowly watch the rest of these 100 people go home.
Thank you, everyone who stayed a little later with us. We really appreciate your attendance today. And yeah, if anybody has, an extra minute and they want to ask something out loud, please feel free to raise your hand. I see Sam's hand is still raised, so I'm going to allow them to talk once more and just see if they have anything to say.
No, I was just wondering, you guys are in Naperville. Can I stop in and talk to you and get some products and some information for a client?
Absolutely. Jen, our relationship manager, is in Naperville in our office. We've got samples of every type and kind that we have to offer. She's the one who sends them right out of that office. So it would be good to know, Sam. She likes to know when she's having guests so that she's there for sure. Because
I won't just hop in. I definitely call. If you give me a number or something, or I do projects here and there and a lot in Naperville.
Okay.
County area. Mostly our projects are all the way from Wisconsin border down to almost Champaign, but I like to stop in and see some of your products. My office is in downtown Wheaton,
Oh, good.
so it's not a big deal. I can stop in and but I will call first.
Okay, Jen would love to have you. I guarantee she loves company. We're so virtual. So
Yeah, well, that would be great. If you can, I send my information for the AIA number.
Yep.
Somebody reply to that and give me the contact information so I can call the number in my phone when the time comes.
Your email, and we'll follow up with you and provide that number for the
I
contact.
appreciate it. Thank you. Now you can mute me.
Okay, great. Sam, appreciate you raising your hand.
Okay.
Cool.
anyone else?
Let's see.
I'll say here if you think of something. We still have 75 people sitting there, so either they went to lunch or they.
Yeah, they might be done with us, but yeah, we'll give it another moment or two, see if anyone else raises their hand. And actually, in case folks are still paying attention to us, let me just type into the chat here my email. So if anybody missed the quick little Acelab presentation at the beginning, feel free to reach out to me at my email here. I just typed it in the chat. I'm happy to connect with you and give you more of a demo, show you how to use Acelab's tools to support your product research flows. So yeah, feel free to shoot me an email over there.
I think I just sent you the phone. I don't think I can write to everybody, but I think I sent our phone number there.
Oh, great.
Everybody wants that. Good.
Great. All right. Yeah, I'll copy this phone number into the chat for everyone else. So that's the phone number to the contact in the Naperville, Illinois office. If anyone else would like to go visit in person, yeah, please feel free to do that. I'm sure that'll be a fun little intro. And
Sure.
all right. So I've completed our poll. Thank you to everyone who answered that poll. We will connect with you over on your Acelab account. So you'll get follow-up information over there. And yeah, we have a record of everyone's questions as well. So I know we got to most of them. But yeah, please feel free to follow up with us after the event with any other questions as well.
Great.
All right, cool. So it seems like that might be it for our questions. Thank you again, Beau. That was really awesome. Great presentation. Great to see so much engagement, so many questions. And yeah, I really learned a lot.
Thank you very much. Bye, everyone.
Bye, everyone. Thanks, everyone.